Hello, fifth period. Today on the board at the beginning of class, you saw something like this, and you did FOIL on each of these, and you came up with the following. And I asked you what you got, and you told me your answers, and I said we'd come back to it, and then we didn't because I wanted to give you a chance to play Battleship with factoring. So let me just come back to that now. Couple things to notice about these problems, the things they have in common. One is that each set of parentheses, same exact thing, different sign. Okay, so you're multiplying two binomials that are the same except for the sign in the middle. Almost like the conjugate. Remember when you're multiplying by the complex conjugate or the conjugate to get rid of radicals or I in the denominator? It's almost like that, what you do when you're doing that. When you multiply by the conjugate, it's the same thing except there's a different sign on part of it. Okay, and just like when you multiply by the conjugate, same thing is happening. Like basically when I do this, I do FOIL, okay, these two things end up showing up. X times x, x squared. 5 times 5, 25, and it's negative. These two things cancel out. This one gives me a negative 5x, this one gives me a positive 5x, so there's no middle term. That's the second thing I want you to notice, is that usually if I multiply two binomials, I get a trinomial. All three of these, I got a binomial. So that's a unique situation. And as we have been doing here, the reason we're talking about this, the reason we're multiplying it, going from here to here, is so that we can look at it again in the context of factoring and go from here to here. Okay, so these all fit a certain pattern, and the pattern is this. This is the square of something, in this case x times x. This is the square of 3x, 3x times 3x. This is the square of something, it's 2a times 2a. Okay, so we've got the square of something. Same thing over here. I have the square of something on the back end. 5 times 5 is 25, 2 times 2 is 4, 3b times 3b is 9b squared. Okay, so I've got something else that's squared. And notice that it always ends up every single time having a minus in the middle. Okay, so this is a specific pattern that we call the difference of squares. Okay, anytime you have to factor a difference of squares, which is literally called that because you are taking the difference, meaning minus, of two things that are squared, the difference between two things that are squared. So that's why it's a difference of squares. Anytime you're trying to factor the difference of squares, basically what you're doing is you're identifying what is it that's squared here, what is it that's squared here, and then it fits into the format of here it's x that's squared. Okay, so that's the first thing that's squared, and here it's 5 that's squared. So it's x plus 5. In this case, this would be a plus b times a minus b. That's the rule right here. Okay, let me give you an example. Let's say you have 16a squared minus 36. This is a really bad example. Sorry, we'll come back to that example. How about, let's do 4m squared minus 49. Okay? If I think it's a difference of squares, which it's going to be, then I have to identify what is squared here and what is squared here. So this is something squared. It's 2m times 2m. So it's 2m squared. This is something squared. It's 7 times 7. So it's 7 squared. So 2m is my a up here, and 7 is my b up here. So basically my answer is just 2m plus 7 times 2m minus 7. And remember, multiplication is commutative, so it doesn't really matter if you write the one with the plus first or write the one with the minus first. Okay? Another example. Let's look at m squared minus 81. Okay? Notice it'll always be a minus because it's difference of squares. If it's not a minus, it's not going to fit this because it can't be a difference. So this is m squared. This is 9 squared. So my a is m, my b is 9. It's going to be m plus 9 times m minus 9. And again, you could write that in the reverse order, m minus 9 times m plus 9. One thing to notice is, I had a thought. I'll come back to it. Let's look at this one. Let's see. The reason this is a special case is because what do these two things have? They have a common factor. They're both divisible by 4. So I would take out my 4 first, and sometimes this will happen. Take out a GCF. This is 4 times 4a squared, and this one is 4 times negative 9. Now, this part, I have to ask myself if it can be factored. It can be. It's a difference of squares. This is 2a squared, and this is 3 squared. So I have a 4 out front still, and then I write 2a minus 3 times 2a plus 3. That's my difference of squares. The point I wanted to make, and I said I forgot it for a second, the point I wanted to make about this is that anytime you start out with 2 terms, the only kinds of factoring we've done where it starts out with 2 terms are either there's a GCF, which you always want to check first anyway, or it's this. There are other situations where you could factor something with 2 terms, but nothing that you've learned how to do yet. So if you start out with 2 terms, like for instance, if it's there we go, 2 terms. First thing I always want to do is look for a GCF. 50 goes into both of these, so I take my 50 out. And then looking at what's left, if I have 2 terms again, see if it's a difference of squares. See if this is something squared here minus something squared here. It is. So this is going to be 50 times x minus 2 times x plus 2. And again, it doesn't matter where you put the plus and where you put the minus. And that's all there is to it. I have also given you some other examples of this on the videos, so feel free to watch those if you need to.